So welcome again. Thank you very much. I can see that most of us are able to get me clearly, and therefore we will start straight away. Now, last time we were discussing correlation and linear regression, and I want to take you a bit back to talk about I want to talk about Anova. Remember last time when we conducted linear regression, we were getting this table here, and this table we said we leave it aside and we are going to explain more about that. I'm not quite sure if I did explain this Anova in this class or in the other class for North America. Probably somebody can confirm to me in this class. Did we explain Anova? You can unmute and let me know, please. Anybody?
I think we did correlation and linear regression. We didn't do Anova.
Okay, fine. So I think I remember I explained in the other class. So I want to go back a bit and explain about Anova, and we are going to illustrate that using some example. So now, when we conducted linear regression, we were getting this output here, and what we said is R was basically the correlation between the two variables. R square was the square of the correlation, and once you square, of course, you get the R square. And what R square meant, it meant that it was what the contribution of the independent variable to the dependent variable. And basically, we saw that you simply multiply this by 100. So 0.948 times 100 says that we have 94.8%. What this means is that the variation in the dependent variable is explained by 84.8% of the independent variable. So you remember the example that we had about the number of policemen and the muggings, which were there. So it means that when you deploy more police officers, then the variation in the muggings will be at a rate of 94.8%. And that's what we had. So we had this output here, and we also had this other output, which of course now this one were giving us this table here was giving us the equation. And because we are dealing with one variable, that one variable, then we talk about the simple regression. It is simple because we had the y variable, which is the dependent variable, and then we had the x, which is the independent variable. So relating two variables in a model like this, we are basically talking about simple regression. In situations where we have multiple regression, then it means that there are so many variables, x1, x2, we have x1, x2, x3, and so forth. And these variables are explaining the dependent variable. And that's why we talk about multiple regression. So many variables, x1, x2, x3, and so forth, explaining the dependent variable, which is y. So one dependent variable, and then we have so many dependent variables. And in that case, the equation will be different. So you will find that you will have b1x, beta 2x1, beta 2x2, and so on and so on, because of so many variables. So I think we explained this. What we did not explain was this table here, which I want to take an opportunity to explain. Now, Anova means analysis of variance. we are looking at what we are trying to analyze in the data is that we are looking at if there is any variation. And the variation that we are talking about is, we are talking about variation within a group or between groups. So I want to use an example here. What we have here, this was a study which was conducted. This was a study which was conducted. I'm trying to look at the charts. Newton, Diwa, I hope you are able to hear me now. Because you've typed you are not able, but I am seeing most of us are able to do that. So maybe Newton, you can confirm if you are following me so that I can proceed. Confirm through the charts, please.
The no was just a response to the question about.
Okay. Thank you very much. Yes, thank you very much. So now what we have here, there was a study which was conducted, and in this study it's about a sleep. You deprive someone of sleep, and how do we do that? You interrupt that person in the middle of a sleep, and you'll find here that we have in group 1 we had 6 subjects, and these 6 subjects, how many of them? We have them here. Now we were trying to interfere the sleep of group 1 subjects, but at the onset of a dream. How do you know that someone is about to dream? You probably look at the blinking of the eyes. You'll see that person trying to make some movement and so forth. So before the onset of a dream, that person was woken up 4 times. 4 times. That is group 1 subjects. Now group 2 subjects, the same thing was done, but not at the onset of a dream, and therefore again this person was deprived of a sleep of the sleep, but not at the onset of a dream. And then we have group 3. Group 3 again, group 5, group 3 subjects had their sleep interrupted, but the number of times were less. And what you are seeing here are the scores. These are the scores. After someone has been deprived of sleep, the following day, you try to measure their anxiety levels. So these are the scores. These are the scores for the anxiety levels. You can see in group 1, we had someone with a score of 9, the score of anxiety levels of 7. We have anxiety level 3, anxiety level 6. These were scores which were awarded, and the scores range between 1 and 20. We had 1 and 20. So you can see here we have the score levels in group 1. We had that. Anxiety levels in group 2, we had this one here, and anxiety levels in group 3, we had this one here. Now, what we want to do is it possible we say that this group and this group, there was no difference? Well, there was no difference in the scores of those particular levels. So what we are doing here, remember we have scores for group 1, group 2, and 3. Now, for us to be able to see if there is any difference between these 3 groups, what we do is we conduct what we call Anova analysis of variance. In other words, we analyze if there is variation in this. And what happens is that in doing Anova, we have 6 steps. We have 6 steps, and I'm going just to mention in passing because the Anova is able to give us the computation of analysis of variance. So now the first step that is involved in analysis of variance is we determine what we call the null hypothesis. Okay, we get what we call the null hypothesis, and we also get what we call the alternate hypothesis. Okay, so what we will do here, we are going, this is just a statement. In step 1, it's just a statement, and that statement may look like this. You can see this statement here, that we are using the word significant difference, and of course we have the three groups. So we state the hypothesis like this. Remember, hypothesis is a tentative answer to a research question. And what we are going to have is there is no significant difference. This is how we state the null hypothesis. There is no significant difference in the anxiety levels of group 3. Remember, we are going to compare these values when we conduct the analysis of variance. And at the end of the day, we will see if there is significant difference or there is no significant difference. But how we state the null hypothesis, that's why it's called null, because it has this word no. It has this word no. No another word for no is null. So there is no significant difference in the anxiety levels of group 3, of the three groups. So we have these three groups that we are trying to compare. And basically what happens in analysis of variance is that we look at the mean for each group vis-a-vis the variations that we have in all the groups. So in step 1, which is very critical, we determine the null and alternate hypothesis. So we state this hypothesis in this manner, and we sometimes state it for purposes of rejecting. We now try to carry out the analysis of Anova. Then once we do that, we now say if this statement, we can say we can determine if this statement is correct or not. If it is not, then we reject. If it is otherwise, then there is no rejection. There's no rejection. We do not reject. Okay. Now, so what we have, we have group 2. In group 2, this is where we calculate what we call the total sum of squares. And the formula is here. I don't want to go deep into this. I want to believe that somewhere in your statistical class, you'll be able to come across this. Now, the sum of squares, the total sum of squares means what? It means that you take the scores and you square them and you get a total, and then you get the difference. You subtract the sum of the scores, which you sum first, then you square and you divide by n. N is the total population. Like for example, what we have here, in group 1, we have 6 subjects, group 2, 7 subjects, group 3, 5 subjects. The total population is 6 plus 7 plus 5. And you'll find that our total population here is going to be 18. So in this formula here, our n is 18. I don't want to go deep into that. Now that's step 1 and 2. In step 3, what we do is we find the sum of squares, but this time between the groups. It's a sum of squares between the groups. Okay. And then in step 4, you find the sum of squares within the groups. So we have a number of computations that will happen here. Like for example, in group 5, we now find the variance estimates. We estimate the variations by doing what? By getting the sum of squares between the groups. So it's a whole manner of computations that we do, and once we do that, just a minute. There's some Okay, thank you very much. I'm back. So what I was saying is we have 6 steps, and I'm going to conduct this. Of course, you may not be able to see the 6 steps, but Excel will basically give you those computations. Now, how do we conduct Excel? I mean, Anova analysis of variance in Excel. Now, this is what we do. Here, I hope you're able to see this Excel screen. Maybe you can confirm to me if you are able to see some data which I've typed in Excel. If you are able to see this data that I've talked about, the anxiety levels, If you are able to see, type yes on the charts, so that I'm sure that you are able to see. Type yes on the charts if you're able to see my Excel. Yes, Janet, thank you very much. Someone else who is able to see. What I've done basically is to type. Yes, Celine, Moses, thank you very much. Yes. Yeah, so that's a confirmation that we are able to see. And basically what I've done here, this is the data that I have just shared, the scores for the sleep deprivation. Yeah, you have this data. What I've just keyed in. We have this data here. So I've just keyed in this data into one column, then the next column, then the next column, and I've symbolized them as X1, X2, and X3. So we have this data here, and we want to conduct what I'm calling analysis of variance. So so we have X1, that's group 1, scores for group 1, scores for group 2, scores for group 3. Now what we do here is, for us to be able to conduct analysis of variance, of course we will click data analysis from your Excel, and once you click data analysis, you will basically group. You just click data analysis, and you have a number of analysis tools here, starting with Anova single factor, Anova two-factor, Anova two-factor without replication. We have correlation, just the way we did correlation. Now, what we do here, remember, we are only analyzing one factor, and therefore we were going to use analysis of variance single factor. There are situations where you have two factors, okay? So we have single factor. Then you click OK. Now, once you click OK, what we need to have here is the input range. Now, the input range, we will select the whole data. You will select from the label of the first data set to the last. So I'll select like this. I'll select like that. Okay. And so you can see here that my input is B2 through D9. That's what you can be able to see. But I want to single out the columns. So in the first row, in this row, we have X1, X2, and X3. Those are the labels for the different groups. So I have to check the labels in the first row to mean that we have this first row. The analysis is not going to include the values. Okay, and once I have done that, then it is good to go. The alpha level is 0.05. We are trying to compute analysis of variance at significance level 0.05. Okay, so that is automatically. You can still change this. You can still change this to significance level 0.01. We have two common alpha levels or significance levels that we use in statistics. So it can be 0.05 or 95% confidence interval, or 0.01, which is 99% confidence level. So we will talk about that later. So I click OK. Now, what happens when I click OK? You can see we are going to have some output here. And in this output, we are going to have the summary. We are going to have the summary. This is the summary for the different groups. You can see here in group 1, that's X1, the count is 6. Okay, the count is 6. There are 6 actually. In group 2, that's X2, we have 7. In group 3, we have 5. And then we have the sums. When you sum everything for group 6, you'll have 38 and so forth. And then we have the average. The average is basically the means. Okay, it calculates the means, and we have the variance. So this is the summary of the analysis of variance. Then now we have this table. You can see this table. Now this is the table that we had when we were running regression, and you can see it had the source of the variation between groups and within groups. So what it does is it calculates the sum of squares between groups, and you can see here we have 70. So this is the sum of squares between groups. Then we have the sum of squares within groups. So going to compute that. In addition, it's going to compute what we call the degrees of freedom. DF is the degrees of freedom, 2 and 15. And how it is getting the degrees of freedom, you simply less the number of rows. You simply less the number of rows that we have. Now you can see here that n was so we have 15 degrees of freedom within groups, and then we have between groups we have 2. The degrees of freedom is basically you take n minus small n. Capital N was 18. Small n is 2. I mean, it's 3. And when you subtract, you get 15. Those are statistical, which I don't want to talk about at this point. Then we have the mean sum of squares. The mean sum of squares, that is in group 5. In step 5, you compute the mean sum of squares, and we are getting those values there. Now, how you get the F ratio? F ratio is basically a value that you obtain when you divide the sum of squares between groups and the sum of squares within groups. So when you divide 35.019 divided by 4.26, then you'll be able to get 8.2. And then we have what we call the B value. B value is sometimes is called the significance value. And that significance value is what has been computed here as 0.0039. And because the significance value was taken at 0.05, this particular value 0.0039 is less than 0.05. And because of that, then we talk about significance level. We talk about significance. Now, how do we interpret this? What we do here, we look at the B value. Now, this B value here, which I'm putting it in red, I want to put it in red. So let me put in that. Now, this value here, 0.03901, is we compare this B value with the significance value. So the significance value was 0.05. Okay. Now, and what are we saying here? What we are saying here is that this value here is less than this. So this value here is less than that. And because it is less than that, then we talk about there is significant difference. So it takes us back to here. It takes us back here where we are saying, is there any significant difference between the groups? And because that value was way much below the significance value of 0.05, then we say that indeed there is no, there is a significant difference. So our statement, where we began by stating the hypothesis, we say there is no significant difference, but there is significant difference because that particular value of 0.05 of 0 point of 0 point I'm going back again, of 0.0039 is less, actually descending towards 0. And because of that, then we talk about there is significant difference. So in our statement that we have here, we are going to reject this statement because it is saying there is no significant difference, but our values, our results is showing that there is significant difference. Now, because of that, then you can see that Anova is basically comparing three groups. It does the analysis of variance, it does the Anova, it conducts the Anova, and what we are concluding is that there is significant difference, meaning that when you deprive subjects of their sleep at different times, it means that the scores will be different, the anxiety levels will be different. And Anova now gives us the information that we are using it to compare different groups. Anova analysis of variance is basically used to compare and see if there is any significant difference between different groups. Okay, so this one now gives us that analysis of variance serves another purpose. It's not modeling, it's not giving us the correlation, but it is basically telling us whether there is any difference, any significant difference between two groups. And because we are looking at only one factor, sleep deprivation, then we are saying this is one-way Anova, or if you like, single factor Anova, because we are only looking at one factor. So now this explanation here serves to explain why we ignored that table when we were doing linear regression. When you do linear regression, one of the table that you are able to get was this table here of Anova, and this table of Anova is actually resembles this other table that we have looked at here. We have looked at in this analysis, in this analysis here that we've done. So the Anova table was meaningless when we are doing linear regression modeling, but here the Anova now serves to give us the comparison between the groups, and that's how it happens. So I will share this data, then you can do Anova analysis, and then you can see what comes out. I will also give out an assignment of the same. A different assignment, then you will be able to conduct Anova. So remember, when you are doing Anova analysis, the data that you have, you will basically arrange that data into columns, okay? But of course, with the labels. So you can see here we have X1, X2, and X3. This is the label for that. And you will basically conduct the Anova using the data analysis tool. You remember last time we were able to add on the data analysis tool for some of us who didn't have. So you will click here. You will click here. What data? Then data analysis. Once you click data analysis, now you select a single factor if it is single factor. If you have two factors, because it's also possible that you have two factors, we may be apart from the anxiety levels that we have in the subjects, we may be measuring something else, maybe temperature, body temperature. We may be looking at maybe blood pressure. Okay, so we are going to have another factor, and if you have such a situation, then you are going to use two-factor Anova because we are replicating for each subject. But for one which you don't replicate, you use this other second option. But we are just conducting single factor Anova in this case. Okay, so you select that, and then once you select, of course, you select the input range. The input range, you say to select everything. Select everything, and then once you select everything, now you specify that the labels is in the first row, and then you're going to have the output. You're going to have that output. This output that we had, this one here, We have this output here. And how you interpret ANOVA is you look at what you have as the p-value. Now, if you cannot interpret using that, or you can also interpret using the F ratio. But for the F ratio, we have statistical tables which you are going to read. You read the F ratio alongside the degrees of freedom, and then you can be able to make an interpretation of the same. So whether you read the F ratio and the degrees of freedom from the statistical tables, or whether you use the p-value, the interpretation will be the same. You will either reject the null hypothesis or you do not reject. Okay, yeah, you do not reject. But what you need to ask yourself here is that when you do the determining the null and alternate hypothesis, the null hypothesis and the alternate hypothesis is one and the same thing, because if I was to state this, so the null hypothesis would be like this, would read, there is no significant difference in the anxiety levels of the three groups. Okay, but if I was to write the alternate hypothesis, it will basically read the same, but it will basically read the same. Let me copy this again. It will basically read the same thing, but you remove the null here. Okay, so this one, the first one here will be the null hypothesis, which is saying there is no significant difference in the anxiety levels of the three groups. The alternate hypothesis will say otherwise. There is significant difference. So in the event that you reject the null hypothesis, then you are going to conclude that there is no significant difference. You are going to pick the alternate hypothesis or alternative hypothesis if you reject the null hypothesis. But if you do not reject, then you simply pick it up and conclude that there's no significant difference in the anxiety levels of the groups. So when you conduct linear regression, you will get that table of ANOVA, but at that point it may be meaningless because you are not comparing values in groups. You are basically trying to find out how much the independent variable is contributing to the dependent variable. Okay, so that one serves to explain that, and I want to believe that that is sufficient to explain to us what ANOVA. Remember, ANOVA has 6 steps, and because you are going to use the Excel, those steps have been skipped. Okay, probably would require a theoretical class for us to be able to have that. Now, up to that point, is there any question? Is there any question? Is there any question?
I have an assistance. Huh?
Yes.
Last time I added the data analysis, but today I'm not seeing it. So can you please show me how to add it again? I don't know what happened.
Okay. So maybe what you will need to do when you click data, let's click data. Are you seeing data menu from your screen?
Yes, I've clicked it. Yeah.
So you are not seeing it, eh?
It's not. I'm not seeing it. I've clicked data and I'm not seeing data analysis.
Okay, let me see. Here, this is the Excel. Now, so in at the top there, at the top of your screen, where we have home, insert, page layout, formulas. Are you seeing data?
Yeah.
Data is there.
Yes.
Just click data.
I've clicked it.
And then you should be able to see data analysis on the right top.
It's not there. At the time it was not there. We added it. Huh? but it's
Okay,
not
no
there
problem.
again.
Quickly, I can give you the formula. So what you'll basically do, you'll click File, right? Click
Yeah.
File, and then you'll come to Options. Okay. Now you'll get this dialog window here. You'll get this dialog window here. You'll come to add-ins here, and then once you click add-ins, you'll go down there. This one here. You'll come down here, so you can see Excel add-ins, and then you'll click Go. Click Go. Now, once you click Go, you check on the FIBA. You check on Analysis Toolbar and Analysis Toolbar FIBA. Just check these two, and then you will click OK. When you click OK, it should be able to add. Maybe you can try that. If it doesn't show up, then you need to restart your Excel application.
It has come.
Okay, thank you very much. So you can practice on that, and we will be there. Now, I want to move to Boxplots. But before I move to Boxplots, I want us to take some small break. Okay. Yeah, you can grab a glass of water, and as I also do the same. And then we will come and look at what we call Boxplots. Yeah, we look at Boxplots. You know how you're able to do that, and we will see how we can create Boxplots. And these are Boxplot there. We'll see how it comes up and how we can be able to detect outliers before we move to how we can compute moving averages. Okay. Yeah, it might take along this time, but this is our last class. So I want us to take a break for 7 minutes. So we should be here at 6:28 so that we can start on Boxplots. Okay. Okay, thank you very much. Sorry, I was not able to get in immediately because of the network issues. Now, if you are able to hear me, kindly type 3 on the charts. Type 3 on the charts. Yes, thank you, Janet, Yvonne, Celine. Thank you very much, sir. You're able to see. Now, what I want us to look at now is what we are calling box plots. Now, sometimes what happens is that we require to summarize our data. Okay, we require to summarize our data in terms of, we want to know if you are given a set of data, then how does it look like? You know, and some of the questions that we may ask ourselves is it normal? For example, supposing you have given out an exam to students, and you want to see what was the average, how many students had below average, how many students had above average, how many marks or what percentage did the first student get, or what did the last student get and the first, and what is the range between the first and the last student. So sometimes we need a summary of data to show us how the data is behaving. Okay. Sometimes when we talk about data is normal, it means that majority of the students are within average performance. Of course, we will have students who are performing very much, so much better, the likes of 70%, 80%, 90%, and so forth. Then we have students who perform extremely below the average, maybe people who get 20%. And you'll find that in most cases, most students are within the average. A number of students will be within the average, but some few will excel so much and some few will be below, will perform poorly. And sometimes you talk about normality of data. Data is normal. Scores of students is a normal variable, meaning that you'll have many students getting within the average. Now, box plots is one tool that we normally use to get those summaries. What is the mean? What is the highest value? What is the lowest value? What is the range? What is the lower quartile? What is the upper quartile? When we talk about quartiles, it means that we arrange our data from the smallest to the highest. And then we look at that middle value. The middle value is the median. And sometimes it's called the 50th quartile. Okay, the 50th quartile. Now, if you divide the data into two, then you have the upper set of data, then we have the lower set of data. The middle point on the lower set of data is the faster half, and that's why we talk about the 25th quartile. And the other one is 75 quartile for the upper data set. And therefore, a box plot gives us a summary of the data. And I want to show it here. Okay. This is an example of a box plot. It's actually a box. As you can be able to see here, at the middle, we have a box. And this box, you can be able to see, it has a middle line. Okay, let me enlarge this a little bit. It has the middle line, then it has the upper line, then it has the lower line, then it has two whiskers. Two whiskers. This is the first whisker up, this is another whisker. Okay, and you will see that all the values are summarized in a box plot. And shortly we are going to see how you generate this box plot in Excel. So you can see here that the lower is the minimum value. If you are trying to look at scores of students, then what is the last student getting? So this is the score down here. This is the whisker. Then the upper whisker is the maximum value. Okay. So what is the highest student scoring? Then we have this whisker here. Now, what we have in the box, is the 25th percentile. We have the median, which is the 5th percentile. Then we have the middle of the upper data set, which is 75th percentile. So a box plot will be able to give us the summary of all these values that we are talking about. And that's why you will find that sometimes for data which is well balanced, you can see the median or the mean is at the center, just the way it's at the center here. But sometimes you will find that this box, the middle line is closer to this lower part than the upper part. So it is not just a picture. It gives you what the data is looking like. Okay. And we are going to use this data here to demonstrate that. Now, what we have here, this is an example of a box plot which I was trying to plot. And you can see here, when I click, you can see, we will run another one fresh. Okay. We are going to run another one fresh. Let me just remove this. Okay. Now, what we have, this is a set of data. It's a set of data. And let me remove this. Sorry. I can put this one here. Now, when you look at this data here, I have what? I have 100 samples in this column here. Maybe I need to explain this data a little bit, and let me hide this first, so that doesn't confuse you. Let me even hide this one. Now, this data set here is a research. This one is a research. This is the length of fish. Okay. Now you can see the first sample. In the first sample, you can imagine somebody is doing some fishing, and you are picking a fish from the pond. Now, when you pick that fish, you take the measurement, and here you can see the measurement of the first fish is 11 inches. We have 10 inches. So in this data here, you are picking the fish. You pick the fish from the pond, and then you measure the length. So data was picked from fish, and at any point in time we are picking 5 fish, and you can see we have the first fish, second, third, and so on. Then we have the second sample, we again pick 5 fish. Then the third sample, we again pick 5 fish. And what we are doing here is we are collecting this raw data and trying to get the sample mean. Now, once I have the sample mean for each, so supposing, for example, different people were picking this sample 1 up to 100. I have from sample 1 up to 100 here. Now you can see that what we have here is we have 100 samples picked probably by different people, and then we get the mean. Now we want to see, how does this data look like? So this is for one person. This is for one person we pick, then we get the mean. For the second person, we do the same thing, we get the mean. Now we want to summarize this data into a box plot and see what meaning does it convey. Now, for us to be able to conduct box plots in Excel, what you basically do is you select the data. Okay, you select the data. In point number 1, you select the data that you want to use for the box plots, and once you select, you will use the box and whisker, which of course is a functionality within data analysis tool. Okay. And once you've done that, then you can choose the chart subtype, and then it can be horizontal or vertical. We are going to look at that. And once you've done that, Excel will automatically calculate quartile 1, quartile 2, quartile 3, and the minimum and maximum values. Of course, all these are represented in the box plot. Okay. And you can be able to customize the appearance of that by adjusting the titles, you adjust the colors and so forth and so on. Okay. So I want us to go straight away and use this data. Now, remember our data here is 100 samples from different people. This is the length of fish. Okay. It's the length of fish. Let me write here fish so that, yeah. So we have this. Now I want to find out how are these means distributed. So we can represent using a box plot. So what we do is from here, we are saying that you first of all select the data that you have. So, and I'm going to do exactly that. I select this. I select the whole of it.
Sorry, you're not sharing that screen.
Oh, it's not showing. I need to share. Oh, sorry. I need to have shared my. So what I have is this is the data here. So I was saying that this is the first fish, that the first child here. Taking the first fish, the second fish, third fish, fourth and fifth. So every child was picking, or every person was picking 5 fish and then measuring the length. And you can see the data is here. Then this one is the second child picking 5 fish again and then getting the mean. So we want to represent this. Means into a box plot. And remember, we said the box plot is giving us the summaries. So the first procedure here is to select the data, right? So you select this data like this. Select up to the last. Yeah, that's the 100th one. So I select that. Then what you do is you click data, then data analysis, right? And here you will select. Sorry. That's a wrong procedure. You select the data first, then you now come here, you click insert. Okay. And then you will click chart. In this group of charts, because the box plot is one of the charts, right? So you will simply click here. This is an extension to show you all the charts. And then once I select that, you click all charts. And in this menu here, we look for box plot. Yeah, box and whisker. Click box and whisker. And once you've done that, you now click OK. You click OK. Now, so when I do that, you can see now we have a whisker here. So you can see that in this plot, we have what? I want to enlarge this as much as possible. Yeah. So this is the fish data. We can say summary of fish data. Okay. Now let's look at what this means. You can see in the lower whisker. We have what? This one here should be around 8 points. No, 9 around 8 point something, or 9, around 9 there. So the lowest value here is 9. If you map here to this, so around 9. So you can see that this is the minimum value. Okay. Then the maximum value is the upper whisker, and that should be close to 12. So it should be 11 point something, probably 11.2. Yeah, maybe something like that. So this is the value, the highest value. This is the lower value, and you can see the distance between the mean or the median and the highest value and the lowest value is almost equidistance. It's almost equidistance. So sometimes you will get data where the whisker is very long on this side and the whisker on the lower side is short. It means that most values are close to the mean. Okay. Now again, you can see that the data is more or less normal because the middle value or the 50th quartile is at the center. It's at the center here. Okay. And this other one is on the upper side. You can see they are almost equal. Then we have these two dots. Now, these two dots means that there is outliers. Outliers are extreme values. They are extreme values. So you can see here we have one. There's an extreme value, and there's an extreme value there. An extreme value of maybe 8 point something, 8 point something. So this is how you run box plots. And a box plot will give you the summary of how the data is looking like. And from a box plot, you can even be able to tell whether the data is normal or not. In other words, you can be able to visualize the variability and the symmetry of the data. And you'll also be able to identify the outliers. Okay. So I know box plots, maybe for those of you who are learning Python, you may have come across box plots. And it's a very important tool that we use to summarize data. Okay. Now, so the box plots will give you the quartiles, as I've said, and this is just but what we are going to have there. So detecting outliers, you look at what the ones which are beyond the lower and the upper quartiles. So any value beyond the upper and the lower quartiles, then you can see those are outliers. Okay. Now, unless there's any question, I will share this data here. I'm going to share this data, and you are going to run it yourself. Probably what you will do is to run the box plot and be able to see how the data is. So if you have scores, for example, and you want to see the summary how it is, then you can run box plots. And the procedure I've given you is what we have there. Now let's move now to moving averages. And I think this should be the last item that I would wish to cover. I'll mention something a little about set scores, and then I think we should. Yes.
Just go back to the box plot.
It's there. Oh, the one that we did.
Yes.
Okay, let me go to the data sets here. Yeah, it is here.
Now, at an analysis point of view, if you have been able to plot that way,
this one
can you be able to? Yes. What is the interpretation of this?
Now, box plots, as I said, gives a summary of the data set that you have. Now, let me, probably I've used some data which is a bit balanced. Sometimes you will find that you see this whisker here, the upper whisker gives you a value. It means a value. You can see this value here.
That's a maximum.
Around a maximum. Then we have the lower one is the lower value. Okay. So and then the center, this center line is the median, or actually the mean. Okay. Median sometimes is the middle value. In fact, in most analytic tools, the middle value you can specify as the median or the mean. Okay. So this middle value here can be the median or the mean. Or you can call it the 50th percentile. 50th percentiles means the middle value. So a box plot will give you a picture of the symmetry of the data. Because apparently most data that we work on are normal. I used an example of a class where you've given out a test. Some few students will score highly. Few students will score very low, but majority of the students will be within the average. So Boxplot will serve to give you the symmetry of the data, how the values are spread within that data set. And that's why we normally talk about the normality of the data. We're going to look at that shortly, right? So Boxplots is a quick way of, when you produce one Boxplot like this one here, it gives you a picture of how the data is. But if you are comparing several other values, then you will be able to compare. Like now, if I had two data sets, let me run one. Let me run this. I select my data here. Let me select these two. Let me say I select the file. Let me say I select this one here. All this. Okay. So I come here, insert, then I come to charts, then I select all charts, then box and whisker, and then I say okay. So you can see here that I have different sets of data, and I can be able to compare these values with these values. So you can see at a glance, I can be able to tell how the data is. Which one has maximum value here? This one has maximum value as a bigger value compared to this one here. Okay, so Boxplots basically serve to give us the summary of how the data looks like. Okay, remember, as a data scientist, your work is to get insights from data sets, and therefore these are some of the tools that you'll be using. Okay, I hope that is answering that question. So I want us to move. I know you can practice that anyway, and you'll be able to tell that. But I want you to, once you run Boxplots, you can as well go to the data itself. Look for maximum values, look for minimum values, look for the means, and then you can now be able to gauge where how the values look like. Okay. So I'll share this data, then you'll be able to use that. Now I want to move to something else, and this is moving averages. I've talked about detecting outliers. Outliers, of course, once you look at that data, you'll be able to see which values are extreme on the lower side or extreme on the higher side. Those are outliers. Okay. Now we have moving averages. Now, in statistics, we have a statistical technique which we normally use to analyze time series data. For example, if you have data that you have collected probably from from January maybe to December, or from Monday to Friday, it has an aspect of time, and that's why we say time series data. Now, once you collect data from which has time component, we can do what we call smoothing by doing what? By doing the averages. And I'm going to use an example. Let me use this data again. You can see here that I have sample mean for the first three. I have this one here, I have this one here, and I have that one. I have these three. I can decide to do what we call moving averages. And when I talk about moving averages, say, for example, you are collecting data January, February, and March. Then the whole year you have collected data. Okay. Now you will find that those data are varying. They are varying across the months from January to December. but we want to see if there is a trend. We want to see if there is a pattern. So what we do something called smoothing. It's a statistical term that we use, smoothing. And smoothing here means that you take the averages so that you can see if there is any pattern. And it's purely a statistical technique. So what we do is, in this data here, the first thing we take the average between the first 3 points. Then secondly, we take the average beginning from the second value. Then we take the average of the next 3. Then once we've done with that, we take the average again of the third value, then we move 3. So at every point, we will be moving a step, but taking an average of the 3 data points. In such a case, we talk about 3-point moving average. Okay? So what I do is take the first 3 values, get the average of that, then the next 3. And when you are taking the next 3, you start with the next value. Then you take the next 3 values, get the average. Then you take the next value again, take another 3 values, take another 3 values like this, and so on until you complete the data set. Now, when you do that, you are doing what we call moving average. You are calculating the average as you move, okay, as you move along. Remember, you are dealing with time series data, okay? Now, you may not restrict yourself to 3-point moving average. You may also have 4-point moving average, 2-point moving average, 5-point moving average. If it is 5-point moving average, you select the first 5 values, then you get the average. Then you select the next 5 again, starting with this first value. And then you go again 5 values and so on. Now, when you want to calculate moving averages in Excel, it is straightforward. So what you simply do, like for example, let me calculate 3-point. So what I will do is I will select these 3 like that, okay, and get the average of this. So what I will do here is I will have an equal sign as usual. I'll have an equal sign. Sorry. Yes, I have an equal sign. Then you use average, the usual average, and then you select the first 3. Select the first 3, and then you close the brackets, and then you press enter. So now when I select this, you can see it has taken the average of these 3. Now I will basically drag this downwards. I'll basically apply. I apply like that, and so forth, up to down there. So you can see here, for the first value, it is the average between those 3. Then the next one is the average between those 3. So it is using relative referencing to be able to calculate the values, okay? And you can be able to see that it's also calculating this. So it is 3-point moving average. Now, why do we do this? Remember I said this is a statistical tool that you use to smoothen data or to find out if there is a trend in time series data. And it applies to data that you have collected over time. Maybe it could be you have collected the first month, which is January, the second month, third month, and so forth, okay? Or it could be you have collected, something in the morning, mid-morning, lunch hour, mid-afternoon, or mid-afternoon, then in the evening. So those are time series data. You want to see if there's a trend. Are the values increasing with time, or they are reducing with time, or they are stagnating with time? So that is the purpose of moving averages. It is used to smoothen data. Okay. So we are saying that you use relative referencing, and you simply put average. You can even put sum, because sometimes it may not be purely the average. Okay. And sometimes we talk about removing noise from the data, by trying to get the averages as you go along, and you can be able to identify trends or patterns in the data, and which of course you may not be able to see from the actual values that you are talking about. Okay. So I'll give you, I'll share this data. I want you to compute 3-point moving average, 4-point, and 5-point moving averages. Okay. Okay, so I want to move to the last thing now, unless there's any question. Maybe I'll move to the last thing, and this is what I've talked about. The normality of data, which we normally use the histogram, and I'm going to lastly talk about that, and from there now, I think we will be done. Any questions so far? Any questions so far? Okay. There's no question. So let me talk about the last thing. Now, look at this chart here. This is a histogram. When we talk about data is normal, we are basically talking about this. That on the extreme left, we have very low values. Then towards the average, we have more frequency of the values. And then towards the higher, we have few students or few subjects. So when data takes this shape here, then we talk about normality of data, meaning that it is symmetric along the center. Along the mean here, this side is a half, this side is a half. It is symmetric, as opposed to when you have data which is right skewed or left skewed. Okay, so one way of trying to check for normality of data is we plot what we call histograms. Histogram is a display or a visualization of the values or the frequencies of the values that you have within a data set. Okay. Now, one of the most important thing in looking for normality of data, checking for normality, is to have a data set and use histogram to display how it looks like. Okay. Now, I'm going to use the same data to create this histogram that we are talking about here. Now, let me do away with the moving averages. Let me do away with the moving averages here. Now, I want to use the same data set here. Let me copy this because it has the formulas. Let me copy aside. Let me copy this one here. I paste values. This again, sample mean, no problem. This is a sample mean. It's only that I'm trying to escape the formulas here. Now we have this data set here. I've selected the 100 values. Now what I want to do is I want to put this data into a histogram. And the purpose of putting it in a histogram is for me to check on the normality. Remember I said when data is normal, it has a bell-shaped curve. This one is a bell-shaped curve. This one here. It looks like a bell or a heap of sand. Okay, so we have normal data. I want to check for normality of data in my data set, and I'm using this data set here to do that. So what I do, I select the data first, right? Now, once I select the data, I will use again the data analysis tool. So I selected that. I select those values. Then I will click on in data. Then I'll come to data analysis. Then here, you remember we did this when we were doing the Anova. So you go to histogram. Okay. I want to display this data on a histogram. So I'll basically click OK. Right. Now it prompts me to input the range. So which is the range that I'm trying to input? I'm going to input, there are two values here. We have the input range, which is actually the values. This one here. So I'm going to select. So I'm going to select this like that. Okay. So it's selecting J2 through J101. Then we have what we call the pin range. What I mean by pin range, sometimes in that particular data set, you would wish to group into classes, okay, into classes. And I'm going to provide you with the pin. I'm going to explain what it means. So the pin range, I'm going to use one here. I'll tell you why I was doing that. Don't worry. So let me just unhide. There is something that I did in here. So unhide. Yeah. You see this, I'm hiding it. Yes. Now I added something called classes here. I'm going to use this as the pin. I'll explain how this pin is coming in. Okay. Yeah. So what I'm going to have, okay, I'm going to have this. I don't know why it's not selecting. It's not selecting what I want to select. Sorry. Okay, so now I'm going to write this. It is not giving me. It's not. My mouse is misbehaving. Let me write the references here. This is, of course, my input range will be this one here. So I'll have J2 through J what now? Through J101. Then my pin is just, when I talk about the pin, I'm basically talking about the classes. So I'll have L2 through L11. So what I'll have is, I'll click here. I'll click here. I'll click here. I'll click here, insert. No, sorry, data, then data analysis. Then I'll select histogram here. I'll select the histogram there. Then I click OK. Then the input range. So the input range will be this one here. So I select it from here down like this, up to here. And then, so this is J2 through J101, yes. Then I select now the pin range. Pin range is like the classes, the pin range is here, so I select from here downwards like this, like that, okay. Have I selected any label? No. So I'll just have that. Yes, so it is L2 through L11. Yeah, that's correct. Then I click now. So I'll have output range. Okay, so I have that one there. And then I'll basically click OK. So click OK. Did I click histogram? This one is giving me what? Let me see if it's giving me the. I selected the histogram. It's not giving me, but it has given me the pin here. It's given me this one here. Oh yeah, correct. So I'm having some values here. Now it is giving me the frequency. It's giving me the frequency of the values. So you can see here, pin is just like the class. So 8.39 is the lowest value. Then we have 11.0 is the 11.8 is the highest. Then these are the frequencies. So the normality of the data will come now from this, which I can select, like this. Okay, and then I basically insert a histogram. So I click on that. Then all charts. Then I select histogram. Histogram is where it's here. Okay. It's giving me different values. Let me check again. Sorry. We have this. Then insert, then chart, then histogram. Histogram. I don't know why it's only giving two values. Okay, I'm going to do this again. Okay. Let me just so we have. Let me repeat this. Should have given me the histogram as well. So sorry, I have to move this one down. So I have this data here. So I click here in data, then the analysis, then I can go to histogram. Okay. Then I input the range, and then I input the pin range. It is giving me the values there, but okay. That this virtual, we have that. Okay. It is giving me the output range, but it's not giving me the histogram itself. Now let me see. How I obtained this one was just inserting the chart. So this one was, you can see here, this is the pin is a frequency. Yeah, I was able to put that now. So let me put here. Select this. Then I click insert. I insert the histogram. Try this column chart, and then I click OK. Did it give me the value? No. It should have given me the pin plus the whatever. I don't know why it is not. Okay. data analysis. Then I have histogram. Then I have input range is this one, output range is that. Now, what I want to do is I want to try this. It should give us once I have this pin here. We have that. We have this. Then okay. Output range missing. Please enter. Okay. Yeah, it's giving me the frequencies. It's not figuring out. It's not giving out me the graph. But let me do this. Let me have value. We have the frequency. Select this, and then I insert the chart here. Now I'll try to find out why this is not working, but you should be able to get these values here as the pin. This one was pin, and then the frequency here. You have the frequency. This one is giving me properly well, but the expected output should be this one here. You see this histogram where we have the pin, and then we have that. Now the procedure is here. I want you to work on this procedure which is here. How you can be able to get these values. Oh, I don't have the procedure here. What I'll do is I'll give you the procedure which worked for this. I'll figure it out and then I'll be able to get back to you. But I want you to get the concept of normality. Normality is basically how the data looks like. And you can be able to see from this histogram that the values are normal. It is bell-shaped, okay? At the center here, probably where we have the mean, the frequency is high. Then on the lower side, we have few, and then we have few on the other side. So the normality of the data which we demonstrated here, normality of data should look like this. Okay. Now I'll figure out that. But just to explain what all these things mean here is when you take the average of all these values, remember we had 100 samples. We had this data here, and we have. Remember we said that we have 100 samples. Starting from this, we are taking 5 fish, and then we get the mean. We have the mean here. Once you have now all this, when you put subject this data into a histogram, it appears normal. It appears normal. So you are moving from the raw data to the means, and we are saying the means is normal. So we have what we call the central limit theorem, where it says that when the values originating from, we have values which are normal, then it gives that summary again as normal. Okay. Stated otherwise, what it is saying is that if we have that variable with a normal distribution, it means that its means will also have a normal distribution. Okay, so that's what the central limit theorem means. That when you collect scores of students, for example, and they are normal, those raw values are normal, then it means even when you get their means, then it's going to be normal again. And that's what the central limit theorem is talking about. And this is a very common theorem in when you are dealing with data in statistics, and therefore it comes up with these assumptions that when the distribution of the means is normal, then it means that that particular mean should be equal to the mean of the population. That's basically what it means, and you can be able to see what we have there. Now, this one takes us to what we call set scores. When data is normal, what you can do is you do what we call standardization. We can standardize normal data into what we call standard normal. And what we basically do here is you take the value of an observation, you subtract the mean, and then you divide by the standard deviation to see how many standard deviations are you able to reach that value from the mean. And you can see this formula here is what? Z is x minus mean over the standard deviation. What we mean here, x value, is actually the raw values like what we have here. These are the raw values. Okay. Now, this mean here is actually the mean that we are having here. So this mean is coming from these values. But it's possible that you can get what is the difference between this raw value and the mean and its mean. And as you get the difference, you divide the standard deviation to see how many standard deviations are you able to have to reach that value. Remember, the standard deviation belongs to what we call measures of variation. It is standard deviation gives us how much a value is varying within a data set. How is the variation of the values from the mean? Okay, so when we compute distance, the distance of that particular value from the mean, you take the raw score, you subtract the mean, and then you divide by the standard deviation. Then you get something called the set score. Set score is basically what? It's basically a value that you get by computing the difference of the actual value from the mean divided by the standard deviation. Okay. Now this is statistics, and you'll be able to get it from when you are trying to check for normality of data. Okay. So sometimes when you have original data, you standardize by taking the distance from the mean, and then you divide by the standard deviation. And by doing so, you are computing what you call the set scores. You standardize, any normal data can be standardized into what you call standard normal. Okay. And this one has to do with the histogram that we talked about, because you, from the mean, you get the difference between the value and the mean in terms of standard deviations, and you now will be able to calculate that. Okay. So I think I have mentioned many things. There is something that I was not able to figure out. I'll figure out and give you the procedure, the histogram. I don't know if it worked in the first place. It's not working now, but I'll be able to figure out that and be able to show you that. So that marks the end of our advanced Excel functions. Indeed, it has very powerful functions, and the only way is for you to discover. The only way is for you to figure out, and once you figure out, then you'll be able to make effective use of those functions. So it is now 40 minutes past 7. So I want us to stop there. We have come to the end of the last lesson. This is basically what we wanted to cover, but I want you to go ahead and discover more. I'll share the data set and I'll be able to share the procedure for getting this histogram that you can see on your screen. Now, the others like the Power Query, I'll not talk about that because they are basically functions in Excel, but they are a little bit more like the others. Remember, we have mentioned these advanced Excel functions. We have only mentioned about not even half of it. So the more you use Excel, you'll discover more and more. Okay, we keep discovering the functions every day, and as need arises, you could be able to get to use a particular feature. So I want to stop there unless there is any question. I want to hand over to the class to make any reactions. So I will stop the recording so that you can make I don't know that I'm able to stop the recording. Okay, so any reactions? Newton, any reaction?
I'm okay.
Thank you. You are okay. Esther? Janet?
I'm okay.
Celine?
I'm okay. Just practice to perfect.
Okay, thank you very much. So hopefully we'll be able to see each other next time. I'll share what I was to share. But if you have any question, probably you can keep in touch so that we can be able to sort it out. So thank you very much and have a nice time. So allow me to end the meeting now.